This is number 10 on a list of problems that a professor at Princeton University gave. So the problem set was just past exam problems. So I thought this was a good one to go over. If you're watching this series sequentially, as of when I post these videos, I'm not going in any particular order. I'm just picking and choosing the ones that I think are more interesting or more challenging that I think are good for my own students. So that's why I'm posting them first before I go over the more typical ones. That there are probably a bunch more videos out there that explain the typical problems as well as I probably can. But anyway, so number 10, this is a maybe I just contradicted myself, but it's a typical intermediate level type of problem, okay? So this problem says, let f of x be integral from 0 to x of sine of t squared dt. Find the Taylor series about a equals 0 of f of x, giving enough terms to make the pattern clear. Also, find the 100th derivative of f of x at 0. Okay, so the reason that I showed you, or not showed you, I'm showing you right now, I guess, all this is in the problem, it says giving enough terms to make the pattern clear. So I don't know if this was intentional of the professor, but well, first of all, I never met this professor, never had this professor, so I don't know if he gave similar problems before. But when I read this problem, I'm thinking we got to do the brute force way of taking derivatives and finding the general pattern. Okay, that's what I'm guessing the professor wanted. But once I started doing it, I had a suspicion that it wasn't going to work well, but I started doing it just because maybe the professor actually wanted it. So this is what happens, okay? If you thought similarly, you'll see that it's a nightmare, actually. And I didn't even complete it. So we start from the 0th derivative, which is just the function itself. Okay, we take the first derivative. That's just fundamental theorem of calculus, so that's sine of x squared. Second derivative, we need the chain rule, cosine of x squared times 2x. Now from here on out, it gets messy. We need the product rule to take the third derivative, so I'm not going to even go over the details. We get minus 4x squared, this line right here. Okay, take the fourth derivative, so derivative of this, you need product rule, chain rule, and all that stuff. Fifth derivative, you can see how messy it gets. Sixth derivative, seventh derivative, I didn't even bother simplifying the seventh derivative. Okay, and if we start evaluating at 0, we get 0 for the 0th derivative, 0, 0, 2, 0, 0, 0, minus 120. So you can see it's a nightmare to try to find a general pattern because you would need to take another 4 derivatives to get a non-zero number if that's the pattern, right? So imagine trying to find the pattern. You have to take maybe 100 derivatives, literally, and then you'll actually answer the other question. But then by the time you take the 100th derivative, the test is over by then, probably. You probably wouldn't even get to the 100th derivative if it's like, for example, an hour test. If it's 2 hours, maybe you'll get there, but then time will be up. So we got to think of approaching this problem a different way. Okay, so that's what this was kind of misleading, giving enough terms to make the pattern clear. So I never had this professor before. So what does the professor mean by that? Well, okay, there's the concept that you can differentiate and integrate power series. Taylor series is a power series. So what if we differentiate f of x? Well, I kind of did that over here already. That's just sine of x squared by the fundamental theorem of calculus, okay? So we can find the power series, Taylor series, Maclaurin series. I usually just say Taylor series, even if it's centered at 0, for sine of x squared, okay? So we start from sine of x, and this is probably what the professor wanted. Expand sine of x term by term. This is how I remember the Taylor series for sine of x, and the Maclaurin series, I should say. It's just the odd powers of x, and you alternate sign. But the factorials are odd as well, okay? So, like any function, if you change the argument or the input, so x becomes x squared, so wherever there's an x on the right-hand side, put an x squared. So that's what I did here, which simplifies to x squared minus x to the 6 over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial, so on and so forth. This is my f prime of x. Notice, because f prime of x is sine of x squared. This is the Taylor series for it. Now we can integrate both sides to get back our f of x, right? So this is just the power rule on each of these terms. That's what I did here. And don't forget plus c. This is an indefinite integral. But we can find that C is equal to 0 since we know that f of 0 is 0. Okay, how do we know that? Well, let's go back up here. F of 0, that's integral from 0 to 0. That's no area under the curve. Value is 0, right? So we should expect f of 0 to be 0. Okay, so x is 0. All these terms will go away, right? So C is 0. So that's how we know that C is 0, and we can just drop it. Okay. Now from here, can we find a general pattern? This is much easier to find a general pattern, right? And we expanded enough terms, hopefully, according to the professor, to find a general pattern from here. So notice we start from x cubed and we're increasing every 4, which is not a coincidence. As we look from up here, every 4 derivatives, we get a value. Okay, not a coincidence. Okay, so we can start from 0, go to infinity for the index n. So every 4, so it needs to be 4n, and we offset it by 3 because we're starting it at 3, okay? And then there should be a constant on the bottom that matches the power, so 4n plus 3 right there, and then the factorial is 2n plus 1 factorial still, okay? And then, of course, you should just quickly plug in some values of n, like n equals 0, n equals 1, to make sure it matches there before you move on to the next problem. So hopefully this was helpful. If you, for some reason, got this exact problem and you were stuck on how to solve it. Otherwise, hopefully this was good practice as well. Oh, by the way, I didn't even go for 100th derivative. Never mind, we're not done with this video yet. So we just found we answered the first part, giving enough terms to make the pattern clear. We found the Taylor series. We found term by term, or we found the first few terms, then we put dot, 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 and we found the general pattern. So how do we find the 100th derivative? This is a very typical problem. Okay. Notice in our expanded form over here, you will never have x to the 100th power, right? Hopefully you can see that. And you can imagine from here, 4n plus 3, you will never get 100 for integer values of n greater than 0. So what does that mean? I'll go over that next. So it's clear from the summation notation of the Taylor series, so even as just said, we can look term by term or from the summation that there's no x to 100th term. So the 100th derivative at 0 is 0, as simple as that. And how can we understand that? Well, let's just imagine a smaller derivative first, like the third derivative. So imagine doing the power rule a few times. It'll be 3x squared and then 6x and then 6, right? For third derivatives. So it'll be 6 if we differentiate x cubed 3 times. Okay, if we differentiate x to the 7th 3 times, it'll be something, or yeah, something x to the 4th power. So there's still x to some power. Similar for this, I'll have x to some power. So when we plug in x to 0, all those other terms would go away, and we're only left with the coefficient out in front of the x cubed term for the third derivative, and the 3 factorial 6. Okay, so that's why they keep asking these questions if you didn't figure that out by now. So I'm going to explain it now. When you take derivatives, so like big derivatives, I'm trying to think of what I want to say. It's just power rule a lot of times. Back to here. It's just power rule a lot of times. So even higher orders of x, so for example, the 100, so anything above x to the 100th power will go away because when you differentiate 100 times, there's still some power of x left in those high order terms. So when you plug in x is 0, the center of the power series, by the way, that's key, those terms will go away. And you're only left with the constants from the matching degree term. So since there's no 100th degree term, the constant is 0. So that's why the 100th derivative at 0 is 0. Okay? Hopefully that made sense. I explained this in other videos as well. If you've been in this channel for a bit, or if you're just looking around my channel to see how to solve similar problems, I've explained this few times. So hopefully, if this didn't quite make sense, maybe a different explanation at a different time I did it would make more sense. So I would recommend you check those out. But anyway, so what did I say over here as well? Alternatively, if the question didn't say give enough terms to make the pattern clear, oh, okay. So this is what I would do usually. If it didn't say give enough terms to make the pattern clear, usually I just keep everything in the summation notation. So sine x, I know it's like this. You should memorize this, okay? So again, f prime of x is sine of x squared. So wherever there's an x, we replace it with the x squared. So that's what I did. And then we use properties of exponents to write it as 4m plus 2, okay? And then we integrate. Remember, this is what we did previously as well. We can integrate even in the summation notation. We can switch to order so we can integrate first. So we just use the power rule. So it'll be x to 4m plus 3 divided by 4m plus 3. And you can see it's matching the above, right? Exact same. So usually I would do it like this, but because the problem says give enough terms to make the pattern clear, you have to probably write term by term, something like this. Okay, now we're at the end of this video. Hopefully this was helpful. Again, I feel like this is a typical, more intermediate level problem, but you can see it's actually totally doable and not too bad at all if you understand the few concepts that are critical, which is differentiating and integrating power series, and these high order derivatives, and how when you evaluate at the center, the only term that really matters is the matching degree term. All right. Hopefully I see you in another video as well. Please give this video a like if it has helped you in any way, and also please subscribe if you're interested in seeing more videos like this. Thanks, and hopefully again see you in the next video. Bye.